Well, thank you so much for joining this lesson. You're most welcome to Shifting Grades Online School. Those who have never subscribed, you are invited to subscribe to our channel and also to share with your friends. So please invite somebody who is expecting the Kjsea 2025. Look at this program as we continue learning. We have the Shifting Grades Online School. We're presenting a powerful program here for the holidays. So for the continuing students and learners in junior school, we invite them from the 20th of November to the 12th of December, 2025, a serious program that will be happening via Google Meet. We shall be covering the term 1 work of 2026. So by the time you'll be opening for 2026 term 1, the work that should be covered that term, you will be already conversant with it in mathematics, in sciences, and in the languages. So please book a date with us. Reach out through our consultation line 0704 15 33 66. Yeah, reach out so that you may know much about our programs. Let's now get to this paper. This is a prediction paper of the science paper 2. Some people are calling it science practical, but it's good for you to know that for the pioneers of CBC and CBE, it shall not be a hands-on practical. People are just going to answer what we call structured questions. So you will respond to questions from structured questions. Be very good in responding to procedures and all that. So let's look at the first task, which is 10 marks. You are provided with a mixture of sand and salt. Sand and salt, and they are already in a beaker. A glass rod, a filter funnel, then a filter paper, a glass beaker, and distilled water. Look at that glass beaker. A glass beaker has also been provided. The first question, describe the steps you take to separate the sand from salt in the mixture. List the correct order. Yeah, steps are supposed to be in order. You don't just put them down anyhowly. Therefore, when you look at the question carefully, you shall discover that sand and salt are already in a beaker. There are people who will waste a lot of time saying, put the mixture in a beaker. Yet, according to this, the setter of that activity, the setter of this item already is telling you that sand and salt are already in a beaker. Therefore, now you have been saved already a whole step. So now, because they are already in a beaker, now you are going to dissolve. You start by dissolving the salt. So add water to the mixture, which is in the beaker. Add water to the mixture to dissolve the salt. Remember, salt is soluble, but sand is not. Add water to the mixture and stir. Actually, you should stir and stir for you to accelerate the process of dissolving. You just stir, of course, using the what? Using the glass rod. And stir using the glass rod. It's good you indicate, yeah? Using the glass rod. That is the step. And the objective of this step is to ensure that you dissolve the salt. Then after you've dissolved the salt now, the next thing now is to separate. And we do this by filtering. So what you do here now, you fix the filter paper in the funnel. Fix the filter paper. The filter paper in the funnel and place them and place them in the glass beaker. Now there's this other glass beaker here. They were already in a beaker, and now filter funnel together with the filter paper are now being placed, and place them on the beaker. That was the empty glass. The empty glass beaker. Yeah, the empty glass beaker like that. Place them on the empty glass beaker. After you've placed them on the empty glass beaker, you are now encouraged to pour the mixture now. It's already having water. So pour the mixture. Pour the mixture into the filter funnel. To the filter funnel. Then now, after this step, you're supposed to note that the salt solution is collected in the beaker as the filtrate, while sand is trapped by the filter paper. As the residue. Yeah. So now sand becomes residue because it didn't dissolve in water. And now because salt dissolved in water, it is now collected as a solution. You have separated to do, but you're supposed to separate sand. Actually, what we needed is sand. Sand has already been separated. So according to this question, we are already through. We have separated sand now. So you can wash the sand to remove. You can now wash the sand. Wash the sand with distilled water. To remove any traces. To remove any traces of salt. To remove any traces of salt in it which might have remained. Then now you can evaporate or heat the salt solution gently. To evaporate the water. And remain with salt crystals. Okay, I've gone to a lot of details, but basically, I think I have broken down the procedure so well. After adding water into this mixture, you're supposed to stir using the glass rod. And I've said the objective of that step is to dissolve the salt because it's soluble in water while sand is not. Then after you've dissolved the salt now, you fix the filter paper in the funnel and place them on the glass beaker, which is now empty. Then pour the mixture into the filter funnel. Once you do that, because the filter funnel is already hosting a filter paper, the filter paper now shall trap the sand a salt solution is being collected, passing through, and gets collected in the beaker. We call it the filtrate, while the sand that remains, we call it the residue. Now the sand can be cleaned and dried. Yeah, the sand can be cleaned and dried. On the other side, we would also like to have the salt obtained. So now that it is dissolved in water, you can now vaporize the water and you remain with crystals of salt. Part B of this question. State the method used to separate sand from the mixture. So sand from the mixture, we used filtration. That one is called filtration. Then salt from the solution that was obtained as filtrate. Now to get the salt, you evaporate. So we use it evaporation. Hapo tumetumia evaporation. Look at part C now of this question, where the examiner is saying, identify two basic lab instruments used in this activity. Two basic lab instruments. Okay, one of the instruments that we cannot fail to use, maybe they need instruments apart from the apparatus stated here. Other instruments that cannot be avoided are like the Bunsen burner for heating or any other source of heat. Bunsen burner. Then we also have the bench. The flat benches, which are used for this particular experiments. Those ones, you cannot fail to use them in this particular activity. Let's continue checking. Now there is a part, there is a part D. State two reasons why it is important to observe safety, lab safety when handling mixtures. Why is it important to observe safety? One is because some of the mixtures have toxic substances and may lead to poisoning, may lead to poisoning. Yeah, you may be poisoned if you don't handle with care. But then as you continue handling, even at some point we are heating. So if we are heating. So if we are heating, we are supposed to handle with care, because the sources of heat may cause burns. There are very many reasons why we are supposed to observe safety. Some of the apparatus being used are made of glass, so they can lead to cuts if they are broken. So you're supposed to be very careful. You're supposed to observe safety so that you may not hurt yourself and other lab users. So some of the reasons why we should ensure that we are safe is because we avoid being burned from the sources of heat, and also we avoid poisoning from some of the substances that are in the mixtures. Again, as you handle mixtures, the apparatus themselves, most of the ones made of glass, they may break and hurt. They may hurt you or even hurt some other lab users there. Look at part E. Give two examples of mixtures used in everyday life and state how they can be separated. We have very many local setup of mixtures and how to separate them. For example, iron and sand, iron and sand, iron filings and sand. And these ones are separated using magnet. The use of a magnet is enough because iron filings are magnetic materials, so they'll be trapped by the magnet and we shall remain with the sand. Then oil and water, a oil-water mixture. These are two liquids which are applied in real life. Accidentally, they may mix accidentally. So once they mix, then we need to separate them using a decantation. Yes, separated using decantation method. You just let them to settle, then you transfer one carefully to a different container. We can also talk about air, the industrial applications of air, whereby air is made of several components. Air is a mixture and not a compound. So the components making up air can be separated using the fractional distillation of air. So you can have air separated using fractional distillation. Fractional distillation. We have very many examples of mixtures. We can have tea and tea leaves, whereby separation is done using a filtration or simply the sieving procedure. Very many. You can give as many examples as possible. We have a world of applications of mixtures in day-to-day life. Remember our consultation line 0704 153366. For the continuing students, we shall be mentoring them throughout the holiday from the 20th of November to the 12th of December 2025. Please be encouraged to advise your brother, your sister in senior school and also in junior school to join our very fruitful programs here so that they may benefit from Shifting Grades Online School. Looking at the second task here, also 10 marks, you provided with a human torso model or diagram, then labels there with kidney, urethra, the ureter, bladder, and the urethra. Okay, then you use it now. You can see this model. You can see this model, a very clear photograph or model. Then you've been now advised to identify and label the four main parts of the human excretory system using the labels provided. So you've been given some labels here. The labels you've already been given them. So yours is now to place them where they belong. So the bean-shaped organs, this is what we call the kidney. This is what we call the kidney. That is now the kidney. You label it like that. Then after the kidney, you can label the ureters. The ureters are two. The ureters are two. So the left one, the right one, ureter. That's the ureter connecting the kidneys. Kidney is the main organ. Kidney is the main organ where the actual excretion takes place. Then now we have urine being transported through the ureter to what we call the bladder. So this is the urinary bladder, or simply the bladder. Yeah, that's the bladder. Then now the urethra. Urethra is now the outlet of urine from the body. bladder stores temporarily. Bladder stores the urine temporarily before it's taken out of the body through the urethra. So that is the four main parts of the excretory system of a human body. Yeah. Look at part B of this. Match each excretory organ below with its function correctly. The kidney. I've tried to mention a few functions as we were labeling the diagram, but kidney, I've said that is where the excretion itself takes place. Therefore, the kidney doesn't store urine temporarily. That is the work of the bladder. It is the bladder that stores the urine temporarily. Then urethra, the one we've labeled last year now. That one carries urine from the bladder to the outside of the bladder. So this is the function of the urethra. And finally, for the kidney, it is the one now that filters. It filters waste products and excess water from the blood to form urine. That is not the work of the kidney. So you use arrows now to match like that. Use arrows to match an organ and its function. Very simple work. I hope you guys are still following. Please remember to subscribe. Remember to share. Remember to invite a friend. Remember to follow up even when you are in senior school for very serious content in our platform, Shifting Grades Online School. Invite friends from all the levels to our serious program. Now, identify the kidney disorder below. We have several kidney diseases. And from the look of things, from what you can see in this kidney, look at the inside of the kidney. What are these? Stone-like structures somewhere there. So this particular disease now, or a kidney disorder, is what we call kidney stones. This one is called the kidney stones. Call it kidney stones. Then more questions after that. We've been told, apart from the disease you've identified in C above, mention two more kidney diseases. So we have several kidney diseases. Some of them is the the UTI, the urinary tract infection. Urinary tract infection. The UTI. We also have the nephritis. You mention any two, nephritis. Nephritis, we have kidney failure or renal failure. You know, the kidney failure. Kidney failure, it's also called the renal failure. Yeah. Those are a few of the kidney disorders. A few of the kidney disorders, properly stated. So we have the last task, also with 10 marks. You are provided with the following. One, there is a 30-centimeter rule and also a wooden block. There is a wooden block here on yoke. Just look at the block there. Then you have the ruler on your desk. Look at the activities that we're going to perform here. Look at the activities. The first one, measure the dimensions of the wooden block. So the wooden block, because it's cuboid in nature, it has a length, a width, and a height. So according to the length here, when you measure properly using a ruler, you discover that the length is 10.1 centimeters. Remember, the examiner has already written centimeters for you at the end of that blank space. So you don't have to indicate your own centimeters, yet the examiner has already said that the units are in centimeters. What you're supposed to know is that in case you make a mistake in the making the observation of that length, you should be within the accuracy of a centimeter rule, whereby it's plus or minus a 0.1. So if this is the exact answer, then we expect you, if you go very far, be within either 10.2 or exactly 10. Don't go beyond that for you to earn the accuracy mark. But remember, you're not supposed to indicate that. You just list what you are getting. For your case, you're not supposed to list that. The one listing just to ensure that you understand what you're doing. Then for the width, according to the width that we have in this diagram, this is equal to 4.6 from this point to this one, 4.6 centimeters, meaning that following the accuracy of a centimeter rule, we are not supposed to go beyond 4.7 and we're not supposed to be below 4.5. Then finally, we have the height. The height is 8.2. 8.2 centimeters. This is now the height. This is the length. Sorry. It's now the length. Then we have the length here. That is the length. So now the height is 8.6. We have all the dimensions. Remember to be very accurate. That's the first 3 marks. Then after that, look at part A. State the type of physical quantity represented by the length. You know, physical quantities are either basic physical quantities or derived, and length is a basic physical quantity. Basic physical quantity. Basic physical quantity. Yeah, that is the length. Basic physical quantity. Then you are told to give a reason for your answer. Why is length a basic physical quantity? This is because that basic quantities are measured directly by the instruments of measurement. It's not like derived quantities which can be computed from basic quantities. So this one is length is measured directly. Length is measured directly. Yeah, from instruments. Using the instruments. You have to measure it directly. In other words, it's not derived from other physical quantities. It is not derived from other physical quantities. You can also say that. It's not derived from other physical quantities. Then look at part B now. Determine the volume of the block in square centimeters. We know that it's cubic, so volume is given by length times width times height. So we substitute now. 10.1, 10.1, 4.6, 8.2. And now we compute from the calculator. Compute now. 10.1 multiplied by 4.6 multiplied by 8.2. Now this gives us 380.972 cubic centimeters. That is how we compute it. I want to mention something here. Assume you are doing this question, then somebody who is not very good in measuring failed the first 3 marks. They got a 0 in part A. They don't know how to measure. But now when it comes to part B, they know how to express volume very well for a cuboid. So in part B, if they write their formula, length times width times height, then they proceed to substitute correctly the values that they got up there. Even if they were wrong, they missed the 3 marks. But now when they use them very well to compute volume, volume is a very different quantity, a very different scale, and it shall be examined differently or independently. So the marks for computing volume, even if you got the wrong measurements, shall be independent, and you shall get all the scores for volume as long as you use the measurements that you recorded yourself up there. Let's say, for example, somebody who is very far from the range. Let's say somebody got here 4.0, then in the next they got 9.3, then here they got 12.0. This person will get a 0 at this point. That person will get a 0 at that point. But now, coming to 9.3, yeah. Now, coming to this other part, if they say this is now student 2 or learner B, volume equals to length times width times height, then they substitute their 4.0, they substitute their 9.3, and they substitute what else? They substitute their 12. They substitute their 12 here. Very well. Then they go ahead to multiply 4 by 9.3 by 12. And they write for us 446.4 cubic centimeters. Now, this person is getting an answer which is very different from the answers that are in the marking scheme. So what happens is that this learner is given 3 marks. Very good work. Then the learner here is also given 3 marks. They got a 0 in part 1, but now they are getting 3 marks. Then the examiner shall write for you their TE, transferred error. So you know very well the concept. You know very well the concept of finding volume. Look at part C. Now express the volume of the Howden block in SI units. To express it in SI units, and this is the last question, to express it in SI units means to change it to cubic meters, whereby we're supposed to divide by 1 million. So 380.972 should be divided by a million, which is times 10 power negative 6. That's to divide by a million. So this is 3.80972 times 10 to the power of negative 4. This is now cubic meters. That's after conversion. You can also write the number here. That's already showing division. We multiply by the negative power of a million. So you can use standard form like that. Or after dividing by a million, you write 0.0003807.972. So it depends like that. If the other person also moves ahead to convert, we are now looking at conversion skills. So they convert their value very well. Their mark is very independent. They score, they still score. So that is it. So thank you so much for joining us. You're most welcome to our serious programs here. Remember to share with your friends. Remember our consultation line, 0704 15 3366. Thank you so much for choosing Shifting Grades. See you another time. Bye-bye.